welcome to Expert Guidance. Today in this video, we'll be covering the topic, the particle model of matter for AQA GCSE Physics. Now in this topic, we'll be covering the topic of density, the change in state, internal energy, specific heat capacity, latent heat, particle motion in gases, and pressure in gases. So let's begin. Now, the first thing that you should know is what is a density of a material. Now, density is defined as mass per unit volume. So if I put this in the form of a triangle, we can get that density is measured as mass over a volume. Now, you need to be very careful in physics with the units. So mass is measured in kilograms and volumes is in meter cube. So density will be kilograms per meter cube. Now, in the exam, they can ask you to find the density, or they'll give you the density and ask you to find the mass. So to find the mass, you'll be doing density times the volume. Or in case they ask you to find the volume, you'll be doing mass over the density. So let's look over an example. So calculate the density of these substances with the mass of 10 kgs and volume 100 meters cubed. Now, density is mass over volume. So we'll do 10 over 100, which will be 0.5 kilograms per meter cube. Now, the next thing that we need to know is how do we measure the densities of different kinds of objects. Now, we could have a regular object like this cube. Now, what we can do in this cube, we can put it onto a weighing scale and measure the mass. And if we know the side of the cube, then we can find the volume by doing side cube, and then we can do mass over volume to find the density of a regular object. Now, how would you find the density of a liquid? For a liquid, what you can do, you can put a liquid into a measuring cylinder and put it on top of the weighing scale. From the weighing scale, you take out the mass of the empty cylinder and then weigh the mass of the liquid, and the volume you can read from the measuring cylinder and do mass over a volume of a liquid. Now, the challenge comes when you have an irregular object. Now, when you have an irregular object like this, it does not have any fixed volume. You cannot measure the volume easily. So what you can do in this case is, mass you can measure by putting it on a weighing scale. Now, for the volume, what do? You can see that we have taken a beaker and we have some water in the beaker. Then we put an object in the beaker and see how much is the liquid has gone up. That is how much liquid that particular irregular object has displaced, and we take that equivalent to the volume of that liquid. So for irregular object, we measure the mass, and for the volume, we find the volume of the liquid displaced when immersed in water, and then we do mass over a volume. Okay, so these are the three ways of measuring the densities of the solid, of a liquid, and of an irregular object. Now, let's do some practice questions on the density calculation. In the first question, it says there's a cube of size 2 meters, mass 2 kgs, find the density. Now, in the second one, they have given you the mass and the density and ask you to find the volume. Now, in all these, take care of the units, pause the video, have a go at these questions, and you can take the help of the triangle that we have just discussed. Okay, all right, now let's see how do we do these questions. The first question, they have given you the side to be 2 meters. So I'll do side cube to find the volume. The 2 cube becomes 8 meters cube, which is the volume. To work out the density, I have to do mass over the volume, which is 2 over 8. That gives me 0.25 kilograms per meter cube as the density of the cube. For the next question, density is mass over volume. So if I rearrange this, I will get volume is equal to mass over the density. My mass is 5 kgs, density is 200 grams. I'll divide the 2. So 5 over 200, that will give me 0.025 meter cube as the density of a liquid. Okay, so I hope these questions are clear to you. Now let's come to states of matter. Now this states of matter is common to chemistry and physics. So we have 3 states of matter. We can look here. These are solids, liquids, and gases. This particle arrangement is very important for you to understand that in solid, all the particles are joined together and there's very few space between the particles. In the liquid, the particles are at a little distance. So you can see the spaces between the particles is little greater than the solid, but not as much as that of the gas. And in gases, the particles are far away from each other. So on the basis of these particle model, each solid, liquids, and gas, they have different properties. You have to remember these properties. So for solid, they have fixed shape, they have fixed volume, they does not flow, they have a high density, there's a low space between the particles, and particles cannot move, they can only vibrate. When we talk about the liquid, there's no fixed shape. The liquid can take the space of the container. So if you put it in a bottle, it will take a bottle space. If you put it in a jug, the liquid will take a jug shape. But it has a fixed volume. Liquid do flow. They have low density than solid, but higher than gas. And particles have space between them and they move slightly. Whereas in the gases, they have no fixed shape and volume. They can flow easily. They have low densities, and the particles have lots of space between them and they move randomly. Okay, so I hope these differences between states of matter is clear to you. Now let's see how we can change the state. So let's take an example of an ice. Ice is a solid. When you melt the ice, it turns into a liquid, and when you heat the liquid, it turns into a gas. Now, when you condense the gas, it's converted into a liquid, and when you freeze the liquid, it converts into a solid. This is how we can change the state. So from solid to liquid, it is melting, but from liquid to solid, it's freezing. Liquid to gas is evaporation, and gas to liquid is condensation. One state of matter can be changed to another by heating or cooling. During the change of state, the mass is conserved, and when the particle is heated, it gains kinetic energy. So the particle starts to move away from each other. So the interparticle space increases and it changes into another state. And when the particle is cold, it loses energy. So the particle moves closer. Therefore, they change from a liquid to a solid. Okay? So I hope all these changes that takes place while heating and cooling is clear to you. In the exam, they can ask you this question like, what happens when you heat a solid? So when you heat a solid, you have to say that the particles gain kinetic energy, and when they gain kinetic energy, particles they move away from each other, and then they escape that attraction and convert from solid to liquid. Okay, so I hope this concept of change of state is clear to you. Now you have to understand this curve. This curve is very important. This is a change of state curve, and this is a heating curve. Now what is happening in this heating curve? A solid is changing into a gas. Now you should understand this curve, and you should also know what is happening at each of the states in the curve, because in the exam they can give you this curve and ask you to label it. Okay, so let's start from the start. Let's suppose we have a solid. Now, if you need to convert a solid to a liquid, you will heat the solid until it reaches its melting point. Now, the melting point of the solid is 0 degrees. As soon as the melting point is reached, there will be no change in temperature until all the solid is melted. So the graph becomes flat at the melting point. And melting point is the temperature at which the ice melts from solid to a liquid without the change in temperature, and for water it is 0 degrees. Now after all the ice has been melted, the temperature goes again up because I need to now convert it into liquid and liquid to a gas. Now once it is melted, the temperature again increases. Now, at this stage, the temperature keeps on increasing of this liquid. And as the temperature touches the 100 degree, which is the boiling point, the liquid starts to boil. And at 100 degree, it will remain at 100 degree until all the liquid is boiled. So boiling point is the temperature at which the water boils from liquid to a gas without the change in temperature. Remember, in the melting point and the boiling point, the temperature remains constant until all the material is being melted or heated. And after boiling, the temperature keeps on increasing until we reach the gas state. Okay? And you have a freezing point. A freezing point is the temperature at which the water freezes from liquid to a solid to form ice without the change in temperature. And for water, it is 0 degrees. Okay, so I hope this curve and change of state concept is clear to you. Now, what happens during the change of state? When we heat the ice is heated, the temperature increases to 0 degrees. At 0 degrees, the melting point is reached. At the melting point, the ice melts to form water. At this stage, there is no change in the temperature, and if we plot the graph, then it will be flat section on the graph. After the ice is melted and forms a liquid, the liquid is heated again until it reaches its boiling point, which is 100 degrees. And at the boiling point, the water boils to form a gas or water vapor without the change in temperature. Okay, so this explanation of the heating curve you should understand, and you should be able to write if it is asked in the exam. All right. Okay, now let's move on to the difference between the two concepts. What is evaporation and what is boiling? Now, students say evaporation is same, boiling is same. But I think if you can look at the two diagrams clearly, in evaporation, the particles just at the surface are evaporating and leaving the liquid. So evaporation is a surface phenomenon. But if you see the boiling, the bubbles are made throughout the liquid. So it occurs throughout the liquid. In evaporation, the water is lost from the surface in the form of water vapors, and boiling is the vaporization of the whole liquid. Evaporation occurs at the temperature lower than the boiling point, and boiling occurs at the fixed temperature at the boiling point. So you should be able to differentiate between evaporation and boiling, and that is also an important part of your spec. Now there are questions on latent heat which are asked in the exam. So you should first know what is a latent heat. So we'll come to that. First, let's see what is internal energy. Now, internal energy is defined as the energy stored by the particles of a substance. So any substance, the energy that is stored in the particles of the substance is internal energy. Now, internal energy is a very broader term. It includes two types of energy. Now, every particle has a kinetic energy and a potential energy. The kinetic energy is the energy due to the particles' individual motion relative to each other, and potential energy is the energy due to the particle individual position relative to each other. So internal energy is nothing but it is the sum of kinetic energy and potential energy of a particle. Now, heating or cooling a particle changes its internal energy and changes the state of the particle. Now, if you talk about the solid, in solid, the particles are not moving. They have very low kinetic energy, so they have the lowest internal energy. On the other hand, the gases will have the highest internal energy. And when we convert a solid to a liquid and a liquid to a gas, their internal energy will also change because naturally their kinetic energy is changing. Okay, now what is latent heat? Now, latent heat is the energy transferred when the substance changes its state without the change in temperature. Okay, so specific latent heat is the energy needed to change the state of 1 kilogram of substance without the change in temperature. All right, now latent heat could be latent heat of fusion, latent heat of vaporization. The latent heat of vaporization is the energy needed to melt 1 kg of a substance without the change in temperature at its melting point. So remember that flat part of the curve, the energy required at that part of the curve is latent heat. And specific latent heat of vaporization is the energy needed to vaporize 1 kilogram of a substance without the change in temperature at its boiling point. Now, to work out the latent heat of any substance, we will do mass times the latent heat. The energy required will be the mass times the latent heat. The latent heat of fusion would be energy which is needed to melt 1 kg of the substance without the change in temperature divided by its mass. So these are the formulas. All right. Now let us look at the question. The question is, how much heat is required to freeze 250 grams of oxygen if its latent heat of fusion is 13.9 kilojoules per kg? And if 167 kilojoules of energy is required to freeze 500 grams of water, what is the latent heat of fusion? Now you can have a look at these triangles, use them, and try these answers. So you can pause the video and come back and check the answers. All right, let's look at this. Now we know that energy is given by mass times the latent heat. So to work out the heat required, we will do mass, which is 250 grams, but the latent heat of fusion is in kilojoules per kg. So we'll convert it into kgs, so which is 250 over 100 times 13.9, which gives 34.75. Next, for the second question, they have given us the energy and asked us to work out the latent heat. So latent heat is energy over the mass. Energy is 167, the mass is 500 grams, which converted to 0.5 kg. And when we divide the two, we'll get the answer 334 kilojoules per kg. Okay, so I hope this concept of latent heat and how the latent heat calculation works is clear to you. Now we can also measure the latent heat from the graph. Now look at this question. Remember, we just did this curve, and they have given us that from here to here, it takes 60 minutes to melt, 2 hours to boil. Okay, so first they ask us to plot the graph of a temperature changes with time for a given mass of ice, say 100 grams. So the mass of ice is 100 grams, and their power supply is 50 watts. They have given us the time, we have noted the time in the laboratory, and then we plotted this curve. Now, how do we work out the latent heat of fusion? Now, we know power is 50 watts. Time is in 60 minutes. When we are talking about melting, it takes 60 minutes to melt, which is 3,600 seconds. So energy is 3,600 times 50, which is 1.8 times 10 power 5 joules of energy has been transferred in that time. Now, energy is M times the latent heat. The latent heat is energy divided by mass. So 1.8 times 10 power 5 divided by 0.1 gives 1.8 times 10 power 6 joules per kilogram as the latent heat of fusion. Similarly, we can work out the vaporization, but time this time is 120 minutes, which is 7,200 seconds. And energy would be 7,200 seconds times 50. And then we can work out the latent heat of vaporization by taking this energy divided by the mass. And that gives us 3.6 times 10 power 6 joules per kilogram. So in the exam, they can ask you to measure the latent heat from the graph or from the numerical data given to you, and you should be able to do both of them. Now, next is what is specific heat capacity. Now, specific heat capacity is the amount required to raise the temperature of 1 kg of a substance by 1 degree, right? Now, let's take an example of water. I say the specific heat capacity of water is 4.2. Let's, for example, and I say that the temperature change of 1 kilogram of water happened by 5 degrees. So how much heat have you supplied? Now we know that to increase the temperature by 1 degree for water, we need to give 4.2 joules of energy. Now since the temperature has gone up 5 times, so it means that we have provided 4.2 times 5 equivalent of energy. So the triangle says energy is mc delta T. Energy is measured in joules, M is mass in kg, C is specific heat capacity, which is in joules per kilogram per degree centigrade, and temperature change is final temperature, take away the initial temperature, which is in degrees centigrade. Now you need to be careful with these units, and you should be able to use these formulas to get the answer. So let's look at these questions. How much energy is needed to raise the temperature of 750 grams of water from 20 degrees to 70 degrees? And specific heat capacity is given to you. How long will it take kettle of 60 watt to bring this change? Now, we know energy is mc delta T. My mass is 750 grams. It has to be in kgs, so that becomes 0.75 times 4200 times temperature change, which is 70 minus 20, and that gives 1.57 times 10 power 5 kilojoules. And power is energy over time, so time is energy over power. I have this energy, my power is 60 watts, I divide the two, so that will give me the time to be 2.7 times 10 power 6 seconds, okay? Similarly, we have the specific heat capacity and the latent heat combined questions. So let us look at this question. They say, calculate the total energy required to convert 750 grams of water at 120 degree at 50 degree to 120 degree, and they have given you specific heat capacity of water and latent heat vaporization. You can pause this video, have a go at this question, and come back and check the answer. Okay, now let's look at this. Now first let's see what will happen in this whole process. So the water which is at 50 degree, if we give that specific heat capacity, its temperature will give 200 degrees centigrade, and it will be using this specific heat capacity, how much heat is required to raise it to 100 degree. When it has raised to 100 degree of water, it will change into 100 degree of steam. So the energy then given would be the latent heat of vaporization. Then after 100 degree centigrade steam, it will convert into 100 degree 20 steam, and there we'll use this specific heat capacity. So to raise the temperature from 50 degree of water to 100 degree of water, we'll use MC delta T. My mass is 0.75, specific heat capacity is 4200, temperature change is 50. So the first heat that is required is 1.57 times 10 power 5 joules. To convert 100 degree water to 100 degree steam, it is mass times the latent heat of vaporization, which is 0.75 times 2260 times 10 power 3 joules, which is 16.95 times 10 power 5 joules. And in the last step, we'll convert 100 degree of steam to 120 degree steam, for which we'll use MC delta T, where mass is 0.75, specific heat capacity is 4200 times 20, which is 0.63 times 10 power 5. Now we'll add all the three energies, Q1, Q2, Q3, and that gives me 19.15 times 10 power 5 joule as an answer. Now this is a very important, it's a long marker question. Make sure you understand this process, that what all energies we'll be using and what all changes will be happening to convert 50 degrees of water to 100 degree 20 steam. Okay, now let's come to the last part, which is pressure in the gas. The pressure in the gas is dependent on temperature and volume. As we increase the temperature, the pressure increases, and that makes sense as well, because when you increase the temperature, the particle gains more kinetic energy, they collide more, and when they collide more, the pressure increases. Whereas the volume and the pressure are inversely proportional. So as you increase the pressure, the volume decreases. As you release the volume, you increase the volume, the particle gets more space. They do not bump into each other too often. The pressure goes down. Okay. So there is a law which relates the pressure and the volume. You have to remember the statement, the Boyle's law. For a fixed amount of gas at a given temperature, the product of pressure and volume is constant. So P times V is constant. Okay, so we can have this question: if a gas at 20 kilopascal occupies a volume of 20 meter cube, how much volume it will occupy if it is compressed to 10 kilopascal? Okay, so you can pause the video, have a go at this question, and come back and check the answer. All right, so we know PV is constant. So P1 V1 equals P2 V2. Our pressure 1 is 20, volume 1 is 20. Pressure 2 is 10, but we do not know what is volume 2. We arrange this and we'll get 14 meter cube should be the new volume. As the pressure has decreased, my volume won't increase. Okay, so I hope this Boyle's law is clear to you. Now the particles in gas, you have to remember that they are moving randomly. The particles collide with the wall of the container and exert pressure. Greater the number of particles, more the collision, and greater the pressure. So I hope this particle motions in gas and the Boyle's law and this unit is clear to you. Now let's look at some glossaries of this topic. Now you should know what is density, melting point, boiling point, freezing point, evaporation, boiling, specific latent heat, specific heat capacity, latent heat of fusion, latent heat of vaporization, Boyle's law, and internal energy. Now what you can do, you can pause the video, try defining these terms, and come back and check the answer. Okay, so density is mass per unit volume. Melting point is the temperature at which the ice melts from solid to liquid without the change in temperature, and for water it is 0 degrees. Boiling point is the temperature at which the water boils from liquid to a gas without the change in temperature, and it is 100 degrees for water. Freezing point is the temperature at which the water freezes from liquid to solid to form ice without the change in temperature, and for water it is 0 degrees. Evaporation is a surface phenomena in which the water is lost in the form of water vapors from the surface of the water at the temperature below the boiling point. Boiling is a change of liquid to a gas at the boiling point, and boiling point occurs throughout the liquid, and it results in the formation of bubbles. Internal energy is the energy stored by the particle of the substance. If you remember, we discussed it as a sum of kinetic energy and potential energy, whereas kinetic energy is the energy due to the particles' individual motion relative to each other, and potential energy is the energy due to the particle individual position relative to each other. The latent heat is the energy needed to change the state of 1 kg of substance without the change in temperature. The latent heat is the energy transferred when the substance changes its states without the change in temperature. Latent heat diffusion is the energy needed to melt 1 kg of a substance without the change in temperature at its melting point. And latent heat of vaporization is the energy needed to vaporize 1 kg of a substance without the change in temperature at its boiling point. Specific heat capacity is the amount of heat required to raise the temperature of 1 kg of a substance by 1 degree centigrade. And Boyle's law states that for a fixed amount of gas at a given temperature, the product of pressure and volume is constant. So I hope this unit is clear to you. It's quite a small unit, but very important. So make sure, as I always say, do check the specification, do check the exam style questions. The link is mentioned in the description below. All these notes that we have covered in this is all mentioned on my website. The link is mentioned in the description box below. If you like this video, then do not forget to subscribe to this channel and click on the bell icon so that you get notified every time I make a new video. Do not forget to join our Facebook group. It's a free Facebook group to get a grade 9 in GCSEs. The link is also mentioned in the description box below. And do not forget to follow us on Instagram at Expert Guidance. And also, I have my 15 weeks free GCSE revision work plan along with the free course material. So it's a complete 15 weeks GCSE preparation course. If you want to join that, it's absolutely free. The link is mentioned in the description box below. You can read it and subscribe to the same. Okay, so I hope you like this video. I'll see you soon in my next video. Till then, happy revising.